we have cosine alpha plus beta plus cosine alpha minus beta. They say this equals 2 cosine alpha cosine beta. Good. So we have to show that the left-hand side equals the right, or the right equals the left, or both can be simplified to the same thing. Where would you like to start? What do you think? Which side we should start with? Any suggestions? The right-hand side or the left-hand side?
Left.
Perfect, I agree. Left-hand side. So I have a formula for this, or an identity, and I have a formula or an identity for this. This one is cosine alpha cosine beta, but minus sine alpha sine beta, plus, for this one is cosine alpha cosine beta, but plus, remember only cosine is twisted like that, sine alpha sine beta. Now when you look at this, what would you do? What is the next step here? What is the conclusion? Any suggestions what to do next? Anyone, please?
You would simplify?
Yes. So these two go away. And then I only have 2 cosine alpha cosine beta, which is nothing else but the right-hand side. So it's done. Very straightforward. No tricks at all. Okay, so let's see. We have 3 more here, or we can go back to the book. You choose. And then an equation. Do we want to look at other?
We do 66.
Very good. So let's look at 66. In 66, we have cosine alpha plus beta divided by cosine alpha minus beta. They say that this is 1 minus tangent alpha tangent beta over 1 plus tangent alpha tangent beta. Okay. Which side would you like to start with? Left or right?
Left.
Okay, we want to start with left, fine. The right-hand side is, I would say, a little bit more sophisticated than the left, but let's start with the left, that's fine. Left-hand side. We just worked on these formulas a second ago. So we have cosine alpha cosine beta minus sine alpha sine beta over the exact same thing, but this is minus, so I would have plus here. Cosine alpha cosine beta sine alpha sine beta. Perfect. Now I have to look to the right-hand side a little bit, and I see a 1 here. And I also look at, I see cosine, cosine, sine, sine, and this is tangent. So I'm going to factor out top and bottom so I can have the 1. I'm going to factor out cosine alpha cosine beta, and we'll see what we have left in parentheses. And of course, I will do the same thing for the denominator. And I have to have the 1 minus and the 1 plus, for sure. So I factor out this. This times this is 1. But when I factor out cosine alpha, cosine beta, and I have sine alpha, sine beta, then this is the fraction sine alpha, sine beta over cosine alpha, cosine beta. Let me write it so you can see it. Sine alpha, sine beta over cosine alpha, cosine beta. So let's check. This times 1 is this. This times this fraction, you simplify the denominator and you recover that. And this is exactly what we have on the right-hand side, because this is tangent alpha and this is tangent beta. And these will go away. 1 and 1. So we have the same thing in the denominator with plus. Sine alpha, sine beta over cosine alpha, cosine beta. And it's done. I just have to rewrite it as 1 minus tangent alpha, tangent beta, and the same thing in the denominator with plus. Tangent alpha, tangent beta. I would have, so this is the right-hand side. So I would have started here because tangent can be replaced by sine over cosine. I would have found the least common denominator. And once you flip, you get this. But maybe both sides have to be simplified to see that the results are the same. It was a very good option. I personally would have started here, but it's absolutely perfect. Even starting from the right-hand side, from the left-hand side, it's fine too. Good. Okay, anything else from these two, or we move on to the equation? Anyone would like to see more, or we move on to the equation?
Can we do 50?
Yes, so let's work on 50. Perfect. So 50 has sine x plus h minus sine x divided by h. Does this remind you of anything? Have you ever seen something like this a long time ago for test 1? Is this a special formula that we looked at before? Does this remind you of anything? Not this, just this. Does this remind you of anything? And how is it called? Anyone remembers this piece? Maybe if I...
difference quotient.
Exactly. Thank you so much. It's f of x plus h minus f of x divided by h, and the function is sine. Sine x plus h minus sine x divided by h. Indeed, the difference quotient for the function sine. Excellent. Thank you so much. Good. So now we have the left-hand side and we have the right-hand side. Where would you like to start?
The right side.
We can, but now this is a little bit more sophisticated if you want than this one. And I'll explain in a minute why. So let's start from the left. So we have a formula or an identity for this. No one can do anything to that, and no one can do anything to h. So the formula for sine x plus h is sine x cosine h plus sine h cosine x minus sine x, everything divided by h. Okay, now I'm looking to the other side and I see a cosine and sine h over h. So there is a cosine x and sine h over h. Now let me refresh your memory on something. Because this, oh, that's not good. Because this quantity is one term, I can rewrite this fraction in the following way. First term over the denominator plus the second term over the denominator minus the third term over the denominator. And I'm going to do that. But I'm going to present it as is on the right-hand side. So I have a cosine x sine h over h. Cosine x sine h over h. I'm going to write it as you see it there. Cosine x sine h divided by h. So now this piece is gone, because this over this is already here. Now the other piece is, obviously I have to factor out sine x, and I'm going to do that. And then I have cosine h minus 1 also divided by h. And that's exactly what this is. So I will write this equals the right-hand side. So by simply expanding this, we obtained exactly what we see here. And they're presented into two terms. So this over this, which is right here, and this over this, which is presented here. And that's the right-hand side. And it's done.
Can you go over it one more time?
Yes. Which part? The last part here?
Yes, please.
Okay. So there are three terms over one term. Everything can be rearranged as this over this, plus this over this, plus this over this. Is this clear? Is this part okay?
Yes.
Perfect. So now I can arrange so this is page 6. So I can arrange a plus b plus c divided by d as a over d. So that's one thing that I wanted to remind you, plus a over d plus b over d plus c over d. Also, I wanted to understand another thing. So this is number 1. Number 2, if I have, let's say, a times b times c divided by d, I can also rearrange this in many different ways. Here's one. Here's another. And I can continue forever. And maybe not forever, but ab times c over d. All these mean the same thing. So coming back to our problem, I had peeked to the right-hand side, and I realized that there is cosine x sine h over h. So these three factors, I rearranged them exactly how I see them here. Because remember, multiplication is commutative. So sine h times cosine x is the same thing with cosine x times h. So I basically put cosine in front, and then I left sine h over h in order to obtain exactly the same piece I had on the right-hand side. Is this step clear?
Yes.
Perfect. Now, this is gone, and I have to grapple with these two. But I see there is a common factor, and I see it here. So I already put it outside. But then what is left? I have to have a cosine h minus 1, and I cannot forget about h. And this is exactly what the identity has on the right-hand side. So again, I played with all these factors because of these, I was allowed to do that because of these properties. First, I split the fraction into 3 fractions because the denominator is only one term. That's why I was allowed to do this. Then multiplication is commutative, associative, so I grouped the numerator the way I pleased. Maybe this, maybe this, maybe this, or maybe AC times B over D, and so on and so forth. I can rearrange them because all of these mean the same thing.
So if you rearrange them out of convenience, so it could like equal the right side.
Yes, because I realized,
Okay.
first of all, I realized that I have to factor out sine x here, and I'm left with cosine h minus 1.
Right.
And the denominator
Okay.
has to stay.
Right.
Because I have to
Mm.
recover from here, I have to be able to go back. So nothing can get lost. Is that better?
Yes. Thank you.
Perfect. Okay, now do we want to look at this equation, or we want to choose other examples, or we move on? So where is my book? Where is my book? Right here. So we have other examples if you'd like to choose from here, or if you want to choose from the handout. So these are other identities. And we had an equation here. How do we proceed? Any questions? Anyone? Can anyone say something, please? So we have equations here. Yes? No? We move on. Do we want to look at this example of this equation or other equations? Or we move on? Okay, we want to look at this one then?
Yes.
Okay, perfect. The square root of 3 sine theta plus cosine theta equals 1. Okay, we don't really like to have sine and cosine in the same trigonometric equation. We want to be able to change sine into cosine or vice versa and just have one equation. It's not really possible, one trig function in the equation, but this is not possible here because the square is missing, right? I'm not going to use plus or minus and so on and so forth. No. But if you look at this, and you also put a 1 in front of cosine, we know it's there. And if we go back to any of our identities, of course not tangent, potentially sine or cosine, potentially plus or minus, okay, then we have an idea of what to do. But remember from the little table that we had for sine and cosine, for pi over 6, pi over 4, and pi over 3, and then for sine, and then for cosine, if you remember, those three numbers, the 1/2 and the 1/2, the square root of 3 over 2, the square root of 3 over 2, and the nice one, the square root of 2 over 2, the square root of 2 over 2. I cannot replace this or this in such a way. I mean, with the square root of 3, there is no such thing. So I'm targeting this square root of 3, and of course the 1/2. But I have to divide both sides by 2 in order to be able to do that. To be able to identify that this is the square root of 3 over 2 something, depending on what we want to change it to. Either sine, sine, or cosine, cosine, or cosine, sine, right? Sine, cosine, or cosine, cosine. So if we go this way or this way, we can do both. So I have to divide both sides by 2. So now I have this good old 3 over 2 sine theta plus 1/2 cosine theta equals 1/2. Then I am allowed to replace these. By what? Well, depending on which formula we want to use. Do we want to use sine cosine and cosine sine and sine cosine, or cosine cosine sine sine? The answer will be the same. So, which angle would you like to use? If you want to use pi over 6, then you have cosine pi over 6 and sine pi over 6. If you want to use pi over 3, then you have cosine pi over 3 and sine pi over 3. Which one would you like to work with? Either pi over 6 or pi over 3. It will not make any difference. The answer will be the same. But we have to make a decision.